Alright, in this video we're going to look at y equals x to the power of 2 over x and try to find the derivative of y with respect to x. Alright, so we've got... Okay, so if I try to think of my normal tools for taking the derivative here, this x and this x, nothing seems to jump out right away. None of the easy techniques. So for this question, I'm going to suggest that maybe we do some fancy algebra work. So specifically, what would happen if we took the natural log of both sides? Now that's alright to do, as long as you make sure that you do it to both sides. It keeps it balanced. Well, the nice thing about this, and what makes me think this might work, is now this stuff is an exponent on something that you're taking the log of. So one of the nicest thing about logarithms is it allows us to take this and bring it down out front. Okay, and I've only got y stuff on the left and x stuff on the right. So I'm going to take the derivative of y with respect to x on this side. So if I took the derivative of y with respect to x, that would be 1 over y dy dx. So y. And over here, I will take the derivative of x with respect to x. So I don't need to write dx dx, that's the same as 1. And it looks like within this, I've got something times something. So I will need to apply my product rule for this. Alright, so product rule can say don't take the derivative of the first part, but take the derivative of the second part. Then don't take the derivative of the second part, but take the derivative of the first part. And for this one, I'm going to kind of write this over here. I'm going to use an exponent rule. Think of 2 over x as 2 times x to the negative 1. So I can just apply the power rule here. And since that's x to the negative 2, put this over x to the positive 2. Okay, so let's see what we've got here. If I go ahead and multiply these two, I've got 2 over x squared. And here I've got a negative 2 natural log of x over an x squared. But it does not quite dy dx. That's dy dx times y. So if I'm trying to solve for dy dx, it looks like I need to multiply... oh, sorry, this is 1 over y. So to get rid of 1 over y, I need to multiply this by y, which means I have to multiply this by y. And this by y. All the terms need to be multiplied by y. Okay, well, I don't like that I have x's and y's in here, but if we look all the way back up here, we know what x is, or what y is in terms of x. So I can actually substitute that in here. So 2y over x squared is the same as 2x to the power of 2 over x squared. And right here, minus 2y, I'm going to put this in place of y, natural log of x over x squared. Alright, and I've got some common stuff here. So both of these have a 2, so I can factor that out. Both of these have an x to the 2 over x. Both of these are over x squared. And so if I factor that out as a GCF, if I undistribute that from these two terms, this would need to be a 1, because this stuff times 1 gives me this. And this would need to be a minus natural log of x, so that this distributed to this would give me that. So in the end, dy dx in terms of just x simplifies down to that.